So this assignable cause could be due to the following situation: inadequate definitions of the specification, different test methodology used by the supplier and the user, non-validated analytical methods, non-validated production procedure, and recently in the variable quality, use of the untrained analysts, incomplete process development, malfunctioning of the equipments and services, non-compliance of the SOP standard operating procedures, and contaminations. So there are different. This is other assignable costs. So there are many tools to prevent, eliminate, and prevention of the assignable costs results in the process stability. So I'm telling this assignable cost makes a process very unstable. Makes a process means hop about the target, resulting the frequent OS situations, out of specification situation, and placing the patients at a high risk. An unstable process is the indications of the incomplete process understanding, right? So to prevent elimination, identification, and prevention of this assignable calls, there are the many statistical tools like kappa, Ishikawa fishbone diagram, 5Y analysis, different techniques to identify the root cause analysis. Okay, so if we identify, if we eliminate, if we prevent this assignable cause that I described before, different causing, then the process is the stable, right? So now, if the process is a stable, is it your process is a capable? So, two words: process stability and process capability. So, process capable, to understand this process capable, let's we uh, concept of the normal distribution curve, right? So, this is the normal distribution curve. So, actually, to understand this normal distribution curve, first we have to consider process means and standard deviation. This is the standard deviation and this is the process means. Okay, and this is the target, right? So process capability, actually it's determines the acceptable products or product outputs. This is very important topics. Process capability. Now, to understand this process characteristics of the normal distribution curve, assuming the process output is normally distributed with the process means and standard deviations. If the upper specification limit is L, this is the upper specification limit. This is the lower specification limit. If the upper specification limit and lower specification limits for a two-side specification, actually in the pharmaceutical industry, there are two types. One is the one-side specification, another is the two-side specification. First, we have to consider the two-side specification. So this USL and LSL for a two-side specification, what to be on either sides of the process means at a distance 1 sigma, we expect 68% of the populations or data will be the accepting and rest 32% with the OS. So already I told before, the higher will be the OS in your process, higher will be the risk factor to the patient. So we have to find out minimizations of the OS. So one sigma process, in the one sigma process, the process OS will be the 32%. And in here, the process capability is mathematically expressed. Just I'm showing. This is the process capability ratio. Is the statistically it can be expressed. Upper specification limit different and minus the lower specification limit divided by the 6 square root of the standard deviation square plus mean bar minus target to the whole square. Okay, this is the mathematical expression of the statistics, and by the application of this mathematical expression, we can measure the process capability ratio. Just I am giving another. This CPA ratio, actually statistically we can easily calculate tolerance divided by the 6 sigma. First, I am telling 1 sigma, already told 1 sigma. Then I told the 2 sigma, 3 sigma, and 6 sigma. In the current scenario, in the third world country, we just maintaining the 3 sigma methods in the pharmaceutical sector. But in the developed country, like you say, European country, Latin America, they are already reached in the 6 sigma approach. Now I'm telling after later on what is the sigma's significance. So process capability, how we improve by the two. One is a reduction of variations in the process, and another is a revising the design tolerance, thereby making the change to the design. Right? This is the uses of the process capability study. See, this slide is very important. Already I told, this is the 1 sigma slides. So, two side specification limits, the process capability ratio, the difference of the upper specification limit and lower specification limit divided by 6 standard deviations. This is a very important mathematical expression practically we approached in the pharmaceutical uh, sector. And for one side specification limit, for the upper specification limit, that means CPU, is the difference of the specification limit divided with 3 sigma. And lower for the lower specification limit, if you measure the lower specification limit, uh, specification limit minus LSL divided by 3 sigma, right? Now the 2 sigma. If we set the UCL and LSL at the distance of the 2 sigma on the either side of the form process means the process capability ratio becomes as follows. For the 2 sigma, difference of the specification limit divided by 6 sigma. Already we know the this one indicates the 4 sigma divided by the 6 sigma, 2/3. This 2/3 I already tell you after so what is the significance of this ratio. And if we said I just giving the concept first. So was a sigma, 1 sigma, 2 sigma, 3 sigma. If we set the upper specification LSL at a distance of the 3 sigma on either sides of the from the process mean, the process capability ratio becomes this mathematical by applying this mathematical expression. This is the CP ratio. Now I am just telling, see, in the just I'm giving the just a minute, this one. This is the normal distribution curve. This is the 1 sigma. 68% population will be acceptable. This is the 2 sigma. 95% of the population will be acceptable. And at the 3 sigma levels, this is the 99.7% acceptable. So you see, so the CP ratio, higher the CP ratio, the lower will be the OS. That means your product is more and more qualitative, and your process means synchronized with the target. Higher the value of the synchronizations of the process means and the target, higher will be the CP ratio. Higher will be lower will be the defectives per million. Just I am giving the before slide.